we'll start talking. So last time we were talking about, not lab 2, we finished up talking about some Java versus Python stuff. And we saw that for the most part, it's just syntax. I mean, that's an easy thing to say. Saying just syntax is kind of maybe feels a little unfair, which, yeah, that's fair because you have to kind of get used to the syntax differences. But the main core concept here is that loops are the same. The way you write functions, methods are the same. The way you write classes is like the same. The variables are the same, except we have to worry about types. Like, that's one of the big differences. And the big difference, I would say, the most annoying difference that you saw was like the input-output stuff. But for the most part, we're not going to be doing a lot of input-output. And like I was saying last time, this type of stuff, I never commit to memory. And usually I'm lazy and do it like this. And I just put this in my method. So I don't even need to put the try catches. And again, I still don't even remember this. Like, every time I want to do I/O in Java, I have to go to Google and Google how I do that again. So yeah, we just looked at a whole bunch of the differences, and we talked about some Java conventions. Just to recap, class names start with a capital letter. Class names have to be the same as the file name, and I think IntelliJ actually enforces this. Functions methods should be camel case, so like some function, some other function. So you don't use underscores like you would in Python. Python, the convention is underscores. Here we use camel case. I guess it's humps like a camel. Variables are also camel case. Constants, though, are the convention's the same as Python, all uppercase and underscores. That's just scratching the surface of conventions, of course, but these are the big ones that are going to pop up more frequently. So how are you going to get used to this? Practice. Yeah, but is there any other silver bullet? Wait, practice. Just practice. Where do you Caddis? Anywhere. Google simple programming practice questions. Great. Go to the 161 textbook and use those questions there, but just do them in Java instead of Python. Practice. Practice, 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 practice. Google it. Exactly. Thank you. Maybe an increase in size would help too. Oh, like that? Is that what you mean? This be the last day to register. Yesterday was the last day to register for a course. Okay, if you send me an email and you really want to register, though, I think there's a way we can override. So if you really want to get in 160 or in 215, email me, and I think we can get that figured out. All right, so back to this. Yeah, so how do you get used to it? Practice. Do you really have to practice? Yes, practice. But I'm really scared right now because Java looks intimidating. If you practice, you'll be fine. That's it. Practice. There's no other magic trick to it other than practice. Everything we talked about, and I know I emphasized this at the end of last class, but everything we talked about is... I do not expect you to go like, oh, okay, so that's how I'm going to do a for loop. I'm going to remember that every time. No. And that's why I have this little warning here. Where is it? If at any point you're thinking, oh, crap, how on earth am I going to remember all these things? You're doing it wrong. As Google it police said, Google it. I'm at 320p. Hold on. Did he say practice? I did say practice. Okay, can we sign up for next year already too? I don't know if you can sign up yet, but okay. Hopefully you end up with a slightly better video quality. I see, Kaylin, you seem to be having semi-consistent issues with the quality. Are you on campus or in town? Or are you still not here in Antigonish? I'm just curious if it's an issue that will hopefully get resolved. Okay. All right. Okay. Hopefully this doesn't persist as an issue, because that would definitely be frustrating. At the very least, things are recorded and posted to YouTube in nice HD. You're using Hotspot. Oh, yeah, that'll probably do the trick. Yep. The recording is done in nice, beautiful HD 1080p, so you can look at there, I guess, but yeah. Starlink, yeah. All right, so next topic, objects review. I want to emphasize this is review. The new stuff is going to be the Java syntax, But all of the core concepts here are the same as in Python. There are a couple of finicky little differences, but the differences are like syntax. The ideas are the same. Wi-Fi on campus produces, okay. So objects are a thing that typically know stuff, can do actions, and can be acted on. Often when programming with Java, we will have interacting objects. Almost everything in Java will be objects interacting with one another. So in like Python, where you could like write a lot of code, not everything had to be an object, where in Java, everything has to be like a part of a class. But that's a future discussion. So objects, just a review. Objects have properties. This is like the data, the variables, but the variables that belong to an object. We call these fields often in Java, but if you use the word like field, variable, like class, variable, attribute, we'll know what you mean. So the properties. These are the values associated with an instance of an object. So going back to 161, imagine we have student objects. Each and every one of you is part of the student class. And I'm using the word class in the Java sense, not like a course class. You are all students, but your instances, you are all a different instance of a student. And because of that, there's a good chance you'll have different values for your properties. If I'm keeping track of students in my program and I want to make a student, if I want to make instances of students, I will probably give you properties like first name, student number, email address. So you all have the same properties, but the values associated with those properties will likely differ because you all have different first names. Behaviors, this is what the object can do, and these are called methods. They're functions, but they just belong to an object. And we usually call these by saying like instance of object dot, then the method name. You might remember that from Python. Class. Every object belongs to a class, and a class defines what it means to be an object of that class. So the class itself is just the blueprint, okay? It's the definition of what it means to be a student. But until I go along and say like, okay, based on this blueprint, I'm going to make an instance of a student called James. That's when I have an instance of that class. I have an object. It's an instance of the student class. For example, think of a human as a class with the fields first name and last name and methods eat and go to bed. All right? We can make Bob Smith an instance of the human class. First name is Bob, last name is Smith. Okay? All objects of the same class have the same fields, but their values can differ. All instances of humans have first name, last names, but Bob Smith's first name is Bob. If we made an instance for Jane Doe, then their first name would be Jane. Right? This is review. If you took 161 last year or the year before, this might be a bit more of a leap review than like everyone that took it last semester, but the same ideas are there, and I'm confident you'll pick it up, so I wouldn't worry too much. So why? Well, classes and objects make abstraction easy, and you might remember how I would talk about abstraction a lot. Abstraction is a fancy word that means like at what level are we considering something, right? If I say, raise your hand if you know exactly how all the moving parts and bits inside your internal combustion engine work, you won't raise your hand. But you didn't need to, because all you wanted to do was jump in your car and drive. You didn't need to know all of that. You didn't need to know at the level of all those working bits of your engine to be able to use your car. Like in Python, you didn't need to know exactly how those list objects work. You just used them. We dealt with these ideas at a certain level of abstraction. We all printed stuff in Python, and we printed stuff out on the screen in Java. We said system.out.println, and then it would print to the screen. But there's a heck of a lot actually going on under the hood there. I mean, you figure like, oh, okay, what's the character? Where is the thing on the screen? Which pixels need to turn on? There's a lot going on. But you didn't need to worry about that. And you could play this game until ridiculous levels. Like, oh, okay, like, move your arm. Okay, great. Well, how did I move my arm? Did I think about moving my arm in terms of, like, contracting and, I don't know, contracting tendons and muscles and whatnot? No. I just, I thought to move my arm. Oh, did you think about the neurons firing in your brain? Oh, let's dig a little deeper. Did you think about the ion pumps that help your neurons fire and the different ions required with the different charges? Did you think about the cell? No, you didn't. You didn't have to, because we operate at a certain level of abstraction. You look at a car, you go, there's a car. Some other jerk might come along and be like, it's not a car, it's a collection of particles. Thanks, asshole. Like, that's not helpful, because they're dealing with a ridiculous level of abstraction that no one's going to, right? All right, it also lets us encapsulate ideas really well. There are arguments for why this isn't great, but we're not going to worry about it. This is a very advanced discussion that's like software engineers would have. But yeah, classes are great because it makes abstraction easy and it can make encapsulation easy. The idea of keeping all the functionality that deals with this part of my program over there. That's what I mean there. High level idea. Your typical class consists of 3 things. Really, it's 2 things, but 3 things. Fields, methods, and a constructor. But a constructor is just a method. It's a fancy method, but it's just a method. It's not a collection of particles. It's a collection of Exactly, right? It's like, well, particles. Like, you can play that game until we get down to ridiculous levels of our universe. Yes, Simon's right. Exactly, right? Because you could play this game, but we like to deal with different levels of abstraction. Okay, in Java, we write our class code in a file with the same name as the class with the file extension, being .java. The human class would be found in a file called human.java. So this is just reviewing the idea of why we like objects. So now we're going to go and make a collection. We're going to make 2 different classes. First, we're going to create a human object, and then a contact list object that's going to keep track of these human objects, okay? All right, the above is very high level. It may be easiest to learn with an example. Let's say we want to make a program to keep track of contact information of our friends. I will make a class that will define what a friend is. Okay, I said human. I guess we'll make a friend class, and then we'll make another class that defines how we will manage a collection of friend objects. I'm going to give you a warning, and this warning comes up a lot in programming, and I said it last time, and I said it a lot in 161, and I mean it in the nicest way possible. Java and all these ideas about how we go about writing these programs, when they were derived and thought of and considered for how it's being done, no one ever thought to themselves, like, but it's being designed so 162 students at St. FX can learn programming. It sucks. It was designed by software engineers for software engineers. It was designed by programmers for programmers, not programmers for people learning to program. That doesn't mean you can't learn it, but because of it, there are some points where you'll have to make a bit of a leap and then go back, and then things will make sense as we go. So if, when you're listening to this, you're like, what? Stick with me here. And it will come together. I promise you. Okay, friend class. What type of information should our friend class keep track of? You know what? Before I even do this, I'm going to go to my Java. It's called lecture 1, whatever. I'm going to create a new class. New class. If you're wondering how I did that, I just went to the SRC part of my my project in IntelliJ, new class. Okay, and it's going to want a name. Friend. Starts with an uppercase. Great. I hear a boop. Hey, screen res got better. Yes, someone last week told me. Oh yeah, no, it was you. You showed me how to make it. Oh, you mean for you, the quality of the stream. Okay, great. I now have a file called friend, and it's for my friend class. You can't see it, but the file here is actually called friend.java, but whatever. And if you don't believe me, for fun, let's go to desktop, lecture stuff, source. See, friend.java. It's there. We can even open this. I don't know, just something simple. And you'll see it's the same because this is literally the same file opened in two different things to view it. But here is our friend class. Nothing in it yet. That's fine. We are not going to write a main method here because we're not asking this friend object to do any of like the function. Well, I want to make sure I word this reasonably well. The friend object is just the definition, the friend class is just the definition of what it means to be a friend. We're going to be using the friend objects in another part of our program. So what information do we want our friend to keep track of? First name, last name, email address, whatever. We could put whatever fields we want in here. We know that we're going to want a constructor, which in Python we would write as underscore underscore init underscore underscore. And what behavior should our friend instance have? So right now when I'm talking about this, I'm talking about the three main things we need. Fields, methods, and constructors. These are the fields. These are the methods. And then I talked about the constructor before, whatever. What methods do we want our instance to have? Well, based on what you remember from Python, maybe we should have those accessor and mutator methods like the getters and setters, how you can get information from it and set information. Maybe we want that repr thing that we talked about in Python. Maybe you want that EQ thing we talked about in Python. But sky's the limit. We can write whatever we want here, right? We are inventing it. We are God, and we are defining what it means to be a friend object for our program. We can add the field hair color. We can add the field favorite song in 2007. You know, we could do whatever we want. We can add whatever we want, but I'm going to keep this one simple. We are God until we forget a semicolon. And then you think you're the dumbest person in the world, and then you realize it's a semicolon, and then you go back to thinking, but I'm still God. It's fine. Do what you want. Why? Because why not? Exactly. Thank you. So, setting fields and writing a constructor. Okay. Now, in Python, we would see something like this. We would say def to start defining our constructor. Oh, you know what? Let's start here. In Python, we would start with class friend. In Java, public class friend. Instead of colon, it's the squiggle. Now constructor def underscore underscore init, open parenthesis, and then we have our parameter list, and we always include self as the first thing in the parameter list. Now, then we would say, okay, well, self's first name is whatever this first name was. Self.last name is whatever that was, and email and so on. We would say self as a way to be like, okay, this is a field that belongs to an instance of this class, where the one without the dot is just the value coming in here. So we would say self dot to be like, okay, this belongs to you, okay? Now, some of you, I bet, are going to love this in Java because it gets nicer. There are two key points here. Well, I mean, there's more than that, but there are a couple of things here I really want to emphasize. In Java, we don't actually need to use self. And I'll come back to this, but first things first. You might remember underscore in Python meant like, oh, it's private, right? I'm not supposed to access it outside. Well, in Java, we just say private, and it suddenly is. The other thing, too, is instead of saying self here, because remember how in Java we have to declare a variable, and then we can assign it a value? We can do it in the same line of code, but like we had to specifically declare it and tell it its type. In Python, we didn't have to do that, but in Java, we do. So what we'll do is we just list the fields up here. Private, string, first name. So we can say private to be like, you're private. String, well, that's the type. It's just a string. And then the variable name. So this is where we declare them. We declare them outside of the constructor, but within the class. Almost always, in fact, if you're not doing it this way, you're doing something wrong. These are going to be at the top of your class. So this is where you're telling your file. This is where you tell the class, these are the fields. These are the attributes. These are the properties, whatever you want to call them. These are the fields that belong to the instances of a friend. Remember, the values will differ, but the fields will be the same. but the values for the fields can differ. So private string first name, private string last name, private string email. Great. That's it. Now, if I hit, like now what this says is, oh, okay, so he's writing a class. Like what Java sees here is, oh, okay, so the class friend has 3 attributes. First name, last name, email. I mean, there's not much you can do with this. You can't really do anything with this object yet. But as far as Java is concerned is, oh, okay, so a friend object has 3 fields. First name, last name, and email address. Great. Why does the word private, what does the word private do in this? It means, yeah, exactly. Same as underscore in Python, it heavily limits access. If that wasn't clear to you, it will become very clear very shortly. And I will show you specific examples of what it means. Private, what about global? I'm not sure what you mean, but based on my interpretation, the answer is very likely yes, but not in the same way you would in Python. Also, don't make global variables. So yeah, we have our 3 fields here. Great. Now let's write our constructor. Okay. Well, our constructor has to be public. And the constructor's name, unlike in Python where you do like this, we don't do that in Java. What we do is we just, the name of the constructor is the same as the class name. It has to be the same. Great. Great. So now this right here is a constructor, but there's nothing in there. I'm hearing a lot of boops. But I need one. Why don't we learn about global for Python? Because we don't want to. Don't. Because global can be very complicated. It can also mess things up. I don't know if we can make bots. I don't think there's an easy API for Blackboard Collaborate to make bots. Okay, so here we're starting our constructor, but it's not taking any fields yet, or parameters yet, but that's fine. We can fix this. You'll notice that, remember in Python, we had to say like self as the first value. We don't do that here. In fact, self isn't a keyword in Java. This is a keyword in Java. So self in Java is this. Self is like a reference to itself. This is a reference to itself. So string, okay, there's a lot of boops. Wait, what's a keyword? Like how like public has a special word or a special meaning. Private has a special meaning. Class has a special meaning. Like I can't say class equals 5 or 4 because it's like, well, no, that's a reserved word. You can't use it. Self was like a reserved word for the reference to itself. So let's give this some fields. String first name, string last name, string email. Great. So now the constructor takes 3 values as parameters. And all I want this constructor to do, we almost always typically want our constructors to be nice and simple. All I want to do is have this assign values to the 3 fields for this class. So I'll say this dot first name equals first name. This dot last name equals last name. This dot email equals email. Great. I'm hearing a lot of boops. If we didn't declare any variables as public, does it default to private? No, if you don't put public or private in front of it, it defaults to something called package private, package public, whatever. That we're not really going to get into because it's kind of like somewhere between public and private, and there's nuances there that aren't very helpful right now. At least it's private. Why do you have to write string in the top of the constructor? You mean right here? Because these are, the parameters are like variables, right? And whenever we declare a variable, we have to tell Java what its type is. So it's like we're saying, okay, here's the constructor for friend. It's going to take 3 parameters. The first one's name is first name, and it's a string. The next one's last name, and it's a string. I can do something like this. private int birth year. There. And int birth year. Great. There. Cool. So every parameter I add here, whenever like a variable parameter is being like declared, we have to say the type. Wait, both though? Like at the top of the class and in the so you mean right here. These are the fields for the class. This first name variable and this first name variable are two different variables. This is probably one of the more annoying things that people have like struggle with, because it is kind of weird because you're like, wait, these variables have the same name. That's a problem. You can't do that. That's ambiguous. When it comes to class, like when it comes to the fields, it's a little different. If you really like, if you want to be very super safe, you can say like in first name, in last name, in email, in birth year. And now here you could say in first name, in last name, in email, in birth year. There. So now it's a little more explicit that like there are different variables. But I'm saying, okay, there's a private field for this class that's a string called first name. Oh, and in this function right here, which happens to be the constructor, the first parameter is called in first name, and it's a string. And I want to assign whatever value that comes in as the parameter to the variable name right here. There you go. Cool. Hopefully that helped. And a cool thing about Java is you don't need to write this. You don't. Remember how like in Python you had to say self dot if you wanted it to be a variable that belonged to the class? In Java, you don't need to. You don't need the this. But as a nice, I'm going to go back to not having the ins in front of all the variables. There. When it's, again, I also don't need them here. Ooh, does it say? What does it say? The value first name assigned to first name is never, oh, okay, it's just telling me it's never used. I actually don't need it here because Java's smart enough to be like, okay, well, it's getting assigned to the class one. But when you put the this, it says like, okay, so first name, whenever it sees first name over here, it's going to assume it's the one like declared for this method in that scope. But if you put this in front of it, it's going to know for certain, oh, that's the one that belongs to this object. What's the point then for this? Like I just said, right? It's just a way to be very clear that like, oh, it's the one for this object. And if you're thinking to yourself, oh, but like if the computer, like, look, if Java knows it's this, like, this is going to work the same with or without the this, well, then why add the this? Well, remember, writing code isn't just for the computer. It's for other programmers. If you showed me this code, I immediately know what this dot first, oh, the this, it belongs to this class. So I don't need to worry about confusion there. This code is arguably a little bit more descriptive. Yeah, hopefully that helps you out. Google it, police. By the way, that's, you win for today. What's the hotkey that cleans up your code? I don't know offhand. I don't know, D? I don't know. There is one, I just can't remember it. Oh, it's impossible to add a bot, that's sad. All right. So there, we have our attributes and our constructor. The class is set up public, so we can access it from other classes. We define the fields to have scope to the class, so they are accessible to the whole class. Wait, fields, oh yes. The fields are private since we want control how they are used. I'll show you an example of this right now. Okay, these are all private. I'm gonna go to lecture 1 and create an instance of a friend object. Friend, my equals a new friend. Now, it wants a first name And they were born in, it's an integer. They were born in like, I don't know, what year? 1999, I don't know. Great. Great. So, like, I can run this code. It doesn't do anything, but, like, I can run it. It's functional. It doesn't do anything, but it runs. There's nothing wrong with it. It's good. Now, watch carefully. If I go here, okay, nope. I'm going to go here, and if I say my friend dot, IntelliJ is going to show you a bunch of, like, methods and things you can do. These are the ones like you get for free. More on them later in the course. These are the ones you get for free, but there's nothing there because like we didn't write any methods or any special things for our friend class yet. But I'm gonna go back here to friend and change these to public. Public, 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 public. Now, so when they were set to private, that meant only code within this file, within the friend.java file, asterisk. There's a catch to what I'm saying, but we're not going to worry about that right now. All of the code in here can access first name when it's set to private, but no other code can. When I set it to public, code from within here can access it, but code from here can access it as well. So I can say something like dot first name. In fact, let's print that out. No. My friend dot first name. Great. And we'll run it. And we'll see John. So because it's public, I can access it. If I go back here, I'm going to change them back to private, 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 private. Okay, save. And now I'm going to, like, one, it's going to be mad at me. In fact, IntelliJ will say, first name has private access in friend. So IntelliJ is smart enough to know, like, well, this does exist, but it's set to private, so I can't run. And let's see what happens if I try to run it. First name has private access in friend, meaning, like, no, you can't do it. This variable, this field, was explicitly set by the programmer to be private, meaning no one should have access to it outside that class because they don't need it. And I want to have control over how and who gets to access this value to just guarantee the integrity of my code. More on that as we go. I'm just showing you how the public and private affects your code. So the private, yeah, okay. The this in the above example lets Java resolve the ambiguity. This.firstName is the class attribute field where first name is a local parameter for the constructor. It is not always necessary to use this in Java like how we did it with self in Python. Okay, great. So we had a couple of fields set. Well, I do want to be able to access and maybe change their first names. Okay, so I'm going to write a getter and a setter. What is the point of keeping code private? We're going to see a lot of that later. But the point is, like, what if I don't want you, like, look, I'm writing the friend class. What if, based on how I'm writing my program, it makes sense that when you create the object, you tell the object what its name is, or you tell the object, the friend, what its field name is, it's John. But once it's set, no one should be able to change it because it's important to me that no one's able to change it. I want it so you can access it, but I don't want it that you can change it. So what I'm going to do is, in that case, like I'll write a getter, public string. I need to specify the return type of all of my methods except the constructor. It knows that it's just going to return an instance of this object. Public string get first name. In fact, if you do like get and then hit tab, it just auto fills in IntelliJ for you, right? So if I do it this way, if it's set to private in here, and I can access it, dot get first name, I can run, Great. I can access the value of that attribute, of that field. It's John. But now I have no way to change it, which is important to me. So it can protect the values in the fields in your objects. Why make a private? You don't. So if it's public, can you still make the constructor outside of the class? I'm not sure what you mean, Harry. You would write your constructor within the class. You just do that. But for fun, I'm going to also write a setter for first name. We'll allow students to change their name. Public string. Oops. Get first name. Public void. This method's not going to return anything. Set first name. In fact, look. If I do set first name tab, look, it automatically just fills it in for me. It's glorious. I'm going to do that for all of my values. Get last name. Set last name. Get email. Set email. Get birth year. Set birth year. Great. So does the constructor have to have the same name as the class? Yes, it must. If you don't, it'll get mad at you. In fact, friend, friends. Look, invalid method type. It's assuming like, oh, you just, obviously this isn't the constructor and you didn't tell what the return type was. It's just, it has to be the same. So this must match this, which must match this. But as you see, IntelliJ is really good at making sure that's the case. Okay. Another reason why you might like to have these like getters and setter methods is like, let's say in set email, I can verify, maybe what I'll do is like, okay, look, I can come along here and write get email, but I can say here, my friend dot set email to, this is not an email address, obv, right? I can hit run, and then suddenly, like, oh, we've got a problem. That's clearly not an email address. So I could add some code here, some logic that checks to make sure it's got like an @ symbol in there, followed by with something plus a .com or .org or .ca, whatever. So I can verify the validity here. Another example here is birth year. If I can be like, if birth year is greater than the current year, don't change the birth year because obviously there's a problem with that. You know, if birth year is less than 1800, they're lying to you. That's not a valid option. So you can add the logic. So the setters, or I guess that's a get, should be set I'm talking about. These setters, it gives us more control over how these values can be accessed and changed, which is important to us. This is what, and a lot of people are now thinking like, yeah, but like, what's the difference to the code? When the difference really is coming down to like how you're using it, and like then what's the difference, right? I'm writing the code, so I'll just make sure I'm using it right. Yeah, but you got to think, if you go get a job, you're not programming in a silo. You're programming on a team, and you want your code to be nice, clean, robust, correct, demonstrably correct and everything, you know? So logic goes in the set, if you want them in the setters, right? You don't need to, but like if you wanted to ensure that, birth year is not greater than the current year, I would put that in the setter, right? And then I could be like, I can throw an exception here if I want, but that's an advanced topic. You are all asking the right questions, and that's good. So getters and setters would be the same for last name. Notice that we do not need the this in front of the first name. Yeah, we didn't here. We could add it, we don't need it. Honestly, in this example, it's likely, okay. You may still feel like making the fields private and then writing, oh, okay. You may still feel like making the fields private and then immediately writing getters and setters is silly. Probably you do. But in this particular example, you're right. That is a silly example. I mean, it's not really there. We are going to be revisiting getters, setters, and why there's importance of public and private as we go throughout the course. And all of these answers, like by the end of the semester, you're going to be like, he never explicitly went through to show me why, but after everything I've seen, it should be very clear at the end of the semester why these things are important. Here's a contrived example to show where to use the setter. Oh, okay. There we go. Perfect. This is what I was just talking about. If email address contains an @ okay, you can do it. If it doesn't, don't change it because there's a problem with the email address. Great. ToString. Remember in Python we had underscore, underscore, repr, underscore, underscore, and that was a special method that would return the string version of the object. We got to be careful. It doesn't print it out, it returns the string. And if you said print some object, the repr would automatically get called. If you remember this from Python, great. If not, not that big of a deal, but it exists. So when we wrote our classes, we ended up overriding the repr. So like it or not, in Python, if you never wrote the underscore, underscore, repr, underscore, underscore, you got one for free if you didn't write it. Python came and like shoved it in your code whether you liked it or not. Not really, but that's kind of how we can think about it. The default version you get of repr in Python is not that helpful usually. It'd usually look something like this. Friend object at 0x7f1. Every time you run it, you'll get a different value. This is basically telling you the memory address and where that object can be found in RAM. Okay? So technically this behavior we got for free is inherited from its closest superclass. More on this far later in the course, not that important right now. The point is, if we never wrote a repr, we got one for free. Same thing in Java. We get the repr for free, except in Java, it's not called repr. It's called toString. And it returns a string. If you don't write toString, you get the default one. And this is where we'll end today. If I go here and say, I'm just going to do my friend, and I'm going to run. You will see friend at 65AB7765. It's kind of, it looks similar-ish to what you would have seen in Python, right? So because it's not that helpful, we would overwrite. We would write our own repr that would get called instead. And I would do something like first name, last name, email address. Great. I would return that string because it's more useful than the default one. So for Java, same idea. Is the address useful? No, it's not. I mean, in certain cases, I'm certain someone somewhere could make use of it, but in general, no. Anyways, that's where we'll end today, and we'll pick up tomorrow. But yeah, hopefully that was, hopefully you enjoyed that. All right, I will see you all tomorrow.